Now for the installation process. Going back to the slide with the thermal gradient, I can't stress this enough that the installation should go under the footer to eliminate this type of thermal bridge. The diagram on the right shows a condition that does happen, but we encourage installers to steer away from this if possible. Although Ampex is not just a regular flat sheet insulation board, it also has a thicker, but the same principles apply here. You want the installation to be continuous. When compared to regular 2-inch rigid foam boards, which are very typical, Ampex would have at least 1 3/8 extra height, depending on the chosen panel R value. So when you're digging the foundation, please ensure that you dig it a little deeper to accommodate for the extra height. It's a very important piece of information to remember specifically for Ampex is that the slab thickness is measured from the top of the nubs or mushrooms, but the concrete volume that we have on our website calculator includes the space between the nubs. In situations that you're very much limited to in height, which can be the case in many retrofit applications, you can use regular 2-inch rigid foam insulation to cover the protruding footer. You can see that short silverboard strips on the right diagram. Then use AMRAD or Ampex to match the same height. This will save you a little height, but will also create more labor when having to carry two material types. This is significantly better than not having any insulation above the footer. Ideally, a little planning in advance can really help to streamline the installation time and making it easier and simple. Now I'd like to show you some typical installations of our product in a few configurations. Here you see just EnviroSheet properly placed over the footer. This type of installation would require a vapor barrier. Typically, a 6mm poly would be installed between the foam and the slab. The poly should run a few inches up the wall and needs to be caulked with sealant around the perimeter. This is a traditional way of insulating a slab, as many of you would be familiar with. When using silverboard, the installation process is very similar. However, it does not need a dedicated vapor barrier. Instead, the seams need to be taped with a vapor barrier tape. Both EnviroSheet and silverboard, 4 inches of crushed stone or gravel is needed under the foam. Around the perimeter, there are two main ways to seal. You can use a sealant between the silverboard and the foundation wall, or use a strip of 6mm poly, overlapped a few on each side, and sealed with tape and caulking to the wall and silverboard. As I mentioned before, Ampex panel also needs to cover the footer to make sure you have proper continuity of installation. The panel should be offset, creating a running bond pattern. You do not need a vapor barrier here unless specifically outlined by your local building code, because the Ampex built-in high-impact polystyrene panel acts as a vapor barrier. AMRAD installation for a basement slab is virtually the same as Ampex. Panels need to be staggered to create a running bond pattern. A vapor barrier tape needs to be used for the seams. A peel and stick membrane needs to be used around the perimeter. As a side note, the peel and stick membrane can be replaced with sealed 6mm poly. More on that later in our presentation. With this system, you do not need to have crushed gravel under it, but the soil does need to be properly graded and compacted. For more substantial concrete slabs in buildings such as fire stations, workshops, warehouses where rebar would be used, rebar chairs can be used. With flat insulation, it's pretty straightforward. When looking at Ampex, one might initially think that rebar chairs cannot be used, but they can. Depending on the size of the rebar chair base, it might be needed to be placed directly on top of a single nub or span between a few of them, as seen on the diagram on the left. For AMRAD, since it is also a flat top, typical installation process is followed. For slab on grade, the situation is much similar to what you have seen for the basement slab, with the biggest difference being in the slab portion itself. The slab would typically be thicker and potentially with reinforcement. Extra parameters would be outlined in your local building code. What you're seeing here is an example of a frost-protected shallow foundation. The biggest thing to keep in mind when using a EnviroSheet is to make sure the vapor barrier is sealed to the wall and that there are a gravel bed to act as a capillary break. Silverboard installation is very similar to EnviroSheet, with emphasis on correct sealing at the perimeter of the wall using tape or sealant. Ampex installation is mostly the same, but very important to remember to make sure the top of the nubs are aligned with the bottom of the slab to ensure that you have the correct slab thickness. Sealing Ampex panel is done with sealant due to the potential irregular edges when trimming any of the panels. AMRAD installation is the same, stagger pattern, tape seams, and using the same peel and stick membrane to seal the wall. Hydronic installation is becoming more common in many applications. We're going to use a typical residential car garage for the next few slides to illustrate a few key points. Insulated garages in general are not very typical, and even if someone chooses to insulate a garage, the slab might not necessarily be insulated. If you want to have a heated garage slab, then you will definitely want to insulate the slab. You would be looking at roughly the same R10 as a basement slab or a slab on grade. Using a virus sheet is the most traditional way of doing this, where a vapor barrier is required to go on top of the insulation. Welded wire mesh will be laid down and the PEX piping will be tied to the mesh. Once the concrete starts pouring, the mesh with the piping will be lifted to embed at roughly middle of the slab. But you don't want the piping to be too close to the surface of the concrete slab either. One side note to keep in mind for this type of insulation is that it's better to use the flat wire mesh, not the rolled one. We wanted to include a slide to illustrate a few key points when using silverboard as a vapor barrier. The seams need to be taped, which I mentioned a few times already. Stapling the piping down compromises the film, which would need to be addressed by using a thicker foam. A vapor barrier or retarder is generally a material that is under 1 perm. Vapor permeance is proportional to thickness of the foam. The thicker the foam, the less breathable the foam is. So if you're looking to staple PEX to silverboard, you would need to use a thicker board, sometime typically around 2.5 inches for silverboard SB35. The other option is to install a vapor barrier under the foam or use welded wire mesh and zip tie the piping to it, both of which are more labor-intensive alternatives. Generally speaking, it is recommended for the vapor barrier to be sandwiched between the insulation and the concrete slab. The last 2 slides bring us to Ampex. In my opinion, the best choice for most typical hydronic installations. Just lay down the panels on some granular or gravel and walk the PEX piping in. This helps eliminate all of the issues with vapor barrier continuity and eliminates the need for additional material and extra steps in the installation. The only thing that needs to be done is to seal around the perimeter, as I mentioned for base and slab on grade applications as well.